Good afternoon. Today we are going to be reviewing data analysis and probability. So first, let's go through a problem that talks about measure of center. The household income of 15 families in a local neighborhood was recorded to the nearest $1,000 in the table below. At the end of the month, a new family is moving in whose household income is $475,000. Determine the most appropriate measure of center to describe this data set. What is the value of that measure? Justify your choice. All right, the first thing I'm going to do is I'm going to look at my information here. I can see that in the table, of all these 15 families, it kind of looks like 32,000 is the least. We have several in the 30s, then several in the 40s, and 50,000 is the highest. So all kind of around a similar ballpark there. But then this new family that's coming in is going to has a household income of $475,000. Ooh, that is a big difference compared to all the ones in that table. So that is something that I need to keep in mind as I am determining the most appropriate measure of center. And as a quick little reminder, we're going to go back here for a second. When we are dealing with measures of center, we have mean, median, and mode as our three options. Mean, or the average, that's the best one to use when all of your data is spread out pretty evenly, and therefore it would be an accurate picture to find the average. The median, which is your middle number, that's the best measure of center when your data contains outliers. And remember, an outlier is a number that is drastically different. It doesn't really fit in with the rest of the data points. And then mode is the best one to use whenever your data is just tightly clustered around one or two values. So now that we've refreshed our memory on this, let's go back to our table and see which one of these is going to be our best bet. Well, all of the tables in our value, all of the numbers in our table here, all of those values, they're pretty similar. They're ranging from 32 to 50, so they're all kind of bunched around together. Then this new one here is drastically different. So that would be an outlier. Since an outlier is present, the median is the best measure of center. And that right there is what I've done for the first part here. It says determine the most measure of center. We just determined that that is going to be our median. Now, oops. Now we need to find what is the value of that measure. So to find the median, that's our middle number, we need to put all of our values here in order from least to greatest. To make things easier, I am going to just write down the first part. So instead of writing 32,000, I'm just going to write 32 because I noticed that all of these numbers are evenly rounded to the nearest thousand. So I can take that little shortcut. So when I write my numbers out, it's not so difficult and time consuming. When I write them out, I'll show you the first couple before I skip ahead to having them all drawn out. Is I'm going to make sure to cross them off after I've written them down. That's a really good strategy when you have so many numbers to make sure you don't accidentally leave one off. So we have 32,000 here. So I would just write my 32, and then I'm going to continue to go down the line. So next up, there's another 32,000. So we're going to write that again and continue on until we have all of our numbers from our data written in order from least to greatest. All right, now that we have all of our data points written out in order from least to greatest, we're going to go through and find that median, find that middle number. And once again, I use, the strategy of checking things off to make sure I find that. I cross off one on each end and keep going until we locate that middle number. Almost there. All right, we are left with two So whenever this happens, whenever you have two numbers that are in the center, to find the true median, to find the true middle, we need to know what is the middle, what is halfway between 36 and 42. Sometimes with your numbers, it can be really easy to do that off the top of your head. Other times, it can be more difficult. So if you're not really sure what's halfway between 36 and 42, the way that we can discover that is basically find the center, find the average between those two numbers. So we will add, oops, that's a terrible 3. We will add 36 and 42 together, leaving us with 78. And then we can divide that by 2 to see what is directly in the middle of 78. And even though you will have access to a calculator, I'll go ahead and kind of work this out long ways because it's always good for us to remember how to do that long division. So 2 can go into 7 3 times. And when 2 goes into 7 3 times, that is 6. 2 times 3 is 6. And we subtract, we're left with 1, bring down our 8. 2 can go into 18, 9 times, which means 39 is our answer. The median, that measure of center, is 39, and technically it's $39,000. So now we have just answered the second part of the question. It says, what is the value of that measure? And then for justifying our choice, well, we kind of actually already did that when we talked about why we chose the measure of center to be the median. And the reason why is we have an outlier, and that would skew, that would mess up your average because it's so drastically different. Therefore, we have to go with the middle number, the median, to get the most accurate picture here. All right, now we are going to work on a question that not only talks about measure of center, but also variability. A group of students in the book club are debating whether high school juniors or seniors spend more time on homework. A random sampling of juniors and seniors at the local high school were surveyed about the average amount of time they spend per night on homework. The results are listed in the table below. So that first column is juniors, the first row is juniors, the second row is seniors. And we have 3 parts to this question. I'm going to read all 3 parts, but then we'll back it up and refocus on part A to begin with. So part A, calculate and compare the measures of center for these data set. Part B, calculate and compare the variability in each distribution. And part C, does the data support juniors or seniors spending more time on homework? And explain your reasoning. All right, so part A wants us to calculate the measures of center. So I first need to determine what is the best measure of center so I know which one to calculate. So remember, mean, the average, is used when our data is pretty well spread out. And then we use our median, so the middle number, if there is a significant outlier. So if we look at our data points here for juniors, we go from 125, we have 80s and 90s. That's all pretty similar. 120, 85, 95. Okay, all of those for juniors look, within the same range. That would definitely be a vote for median. Oh, sorry, for mean. And then for seniors here, we have lots in the 60s, the 70s, the 80s, but we have this one right here that's 35, and that is pretty different from the rest. So with that one, the median would be better. Well, here's the trick here, is even though we can have one that's better than the other, we need to make a decision, because if we're going to be comparing the juniors to the seniors, we need to have the same measure of center for each. So in this case, we're going to go ahead and be on the safer side of things and do the median, because the median will work for both. The average might be better to use for juniors, but it's definitely not going to give us a good picture for seniors. So therefore, the median, that middle number, is going to be the best one for us to use. Remember, when you find median, the middle number, we need to put all of our data points in order from least to greatest. And we're going to do that first for the juniors, then we will do it for the seniors. All right, we have now taken the juniors, which are in red, and the seniors, which are in blue, and written them in order from least to greatest. Now that that's been done, we can find the median. I'm just going to go through and cross one out on each end, and we're working our way towards that middle number. And then we see we have two numbers in the middle, but they both happen to be 95, which makes it easy. The median, the measure of center for juniors, is 95. Now let's do so with our seniors. And once again, the two that we happen to have in the middle are the same, making it easy. The measure of center, the median for our seniors, is 80. So we have answered part A. Now let's move on to part B. Calculate and compare the variability in each distribution. Well, remember that when you're finding the variability, you can either use the range or the interquartile range. In this case, we're going to use the regular range. And remember, to find range, that's when you take the largest value and subtract it from the smallest. We're finding that difference. So if we come here to our juniors, which are in red, we have our largest, which is 125, and we are going to subtract that from our smallest of 80. So 125 minus 80 is 45. So let's label this. This is for part A, and then this is for part B. Now we need to do the same with our seniors. The largest is 175, and we're subtracting from that the smallest, which is 35, giving us the answer of 140. So now let's move on to part C. Does the data support juniors or seniors spending more time on their homework? Explain your reasoning. So we have not only the data points to look at, we can look at the measures of center, we can look at that variability to help you make your decision and support that for part C. Well, when I look at this, I notice that the two data sets are pretty different. With the juniors, it's all pretty even. It's all, a pretty even spread of, all right, a lot of them are spending about 95 minutes, and the difference, so the variability between the high and the low, is only 45 minutes. So that's not a very big gap. That means our data is pretty well centered. It's pretty viable. But then if we look at our seniors, that's where those are the ones that told us we had to use the middle number, because we have that outlier. We have, 175 minutes here, but then we have 35 minutes. That's a huge difference. Look at that range. That range is 140 minutes. That is a drastic difference. So it's not really all that viable. But our middle number, our average, was 80. So I would be one that would be inclined to support that the juniors do. I feel like their data is a little bit more standard. It's more evenly spread across the board. We're with the seniors. Some of them are spending a lot of time, some aren't spending very many. But the juniors as a whole, they are spending quite a bit of time on homework. It's pretty consistent. So that would be my personal choice and the reasoning behind that. And whenever you're working with data and statistics, sometimes there is a clear-cut answer. Other times you maybe have to really dig at it, look at the options and say, I think this one is the best choice. And as long as you can make sure you back that up with reasoning, you back that up with the math that we did here, the measure of center and the variability, you'll be good. All right, next up, we're going to talk about population and samples. A random sample of the 1,200 students at Mooresville Middle School was asked which type of movie they prefer. The results are compiled in this table below. And we have 3 parts again. So I'm going to read all 3 parts, but then I go back and just focus on one at a time. In my opinion, that's a good test taking strategy. So you can kind of see the picture as a whole, but then focus on each one to make sure you don't miss anything. Part A, use the data to estimate the total number of students at Mooresville Middle School who prefer horror movies. Part B, use the data to estimate the total number of students at Mooresville Middle School who either prefer mystery or science fiction movies. And part C, suppose another random sample of students was drawn. Would you expect the results to be the same? Explain why or why not. All right, so we are given a sample, so a small piece of the picture, and we are using that to estimate what the entire answer would be, what it would be as a whole and for a population. Remember, when we're working with that, that is when we want to use proportions to solve. So with a proportion, that's when we have 2 ratios, typically written in fraction form, and they are equal to each other, which is what we have here. We're like, this is a sample, and that's equal, or it's estimated to be approximately equal to the population as a whole. So first for part A, we are being asked to estimate the total number of students who prefer horror movies. So the first thing we're going to do for part A is we need to identify the sample because that's the information we're given as a whole. We know from that sample size that 10 students prefer horror movies. So 10 students prefer horror movies. And then our denominator needs to be the total number of students that are in that sample size because our first ratio is all about the sample. So that needs to stay together. 10 from the sample liked horror movies, and then that's going to be have a denominator of the total number of students. They didn't tell us that, but we can figure it out. They have all the numbers for us in the table. We need to add them up, and that's how many people are in that sample size. So we can add 15 plus 12 plus 3 plus 10, 4, and 6. There were 50 people surveyed. So this right here is our ratio for the sample. 10 out of 50 students interviewed like horror movies. And we are going to set that equal to the ratio, what it would be for the population for the whole school. Well, in this case, I don't know how many students prefer horror movies. And that actually kind of matches because that's what my question is wanting me to do. My question is, how many like horror movies from the whole school? So that is our unknown. That's going to be our X. And then the denominator still needs to be the total number of students. We have to have the labels match that way. When we are told this is how many students are at the school. Now that our proportion is set up, we can use cross multiplication to solve. So first, I'll multiply this way across. So 10 times 1,200 is going to give us 12,000. And then that is equal to when you multiply the other way across. So 50 times x, which would just be 50x. Now we have a one-step equation that we can solve. 50 times x. Remember, when you're solving for equations, you do that inverse operation. So the inverse of multiplication is division, and we're going to divide both sides by 50. 12,000 divided by 50 is 240. And 50 divided by 50 is 1, leaving us with just one simple x. So that means we can estimate that about 240 students in all prefer horror movies. Right, part B. Use the data to estimate the total number of students at Mooresville Middle School who prefer either mystery or science fiction movies. So here we have 2 types. We have mystery and science fiction. Because they can like one or the other and it still works, we're going to add these together to give us a total of 12 students like either mystery or science fiction. And there are 50 total students in that sample. And then that is set equal to our population ratio. And we don't know how many students. That's what we're trying to estimate here. But we do know that in the total population, there is 1,200 students at the school. Once again, we can cross multiply to solve. Actually, before I do that, let me back up and clarify something. The most important part when you're setting up these proportions, we already talked about it on the first one, is making sure that, the sample one is together and the population one is together. But another key factor is then when you look straight across, you need to make sure that your labels match. So in this case, these are the 12 students that like the mystery or science fiction. And that X has that same label. We don't know how many like mystery or science fiction for the total population. And then the denominator labels need to match. We have 50 total students, and then we have 1,200 total students. So that's important to make sure you don't get your ratio backwards, and then therefore the whole problem becomes wrong. So really watch those labels. Sometimes what I even like to do is I label the fraction so I don't forget. Like I could have written out 12 mystery/science fiction over 50 total. And then that helps me visually see the labels. So when I set up my second ratio, my second fraction, I can make sure I have the numbers in the right places so the labels are the same all the way across. All right, now let's get back to solving. So when we cross multiply, we are first going to multiply 12 times 1,200, which gives us 14,400. And that is set equal to 50 times x. We need to solve this equation for x. Divide both sides by 50. And remember, you are allowed to use a calculator on this, which is helpful when the numbers are this large. So we are estimating that 288 students like either mystery or science fiction movies. All right, and then part C. Suppose another random sample of students was drawn. Would you expect the results to be the same? Why or why not? In this case, I would say yes. I mean, they might be a little different. Maybe I would get 245, or I would get 290 for, part B. But that's kind of the whole purpose of drawing information from a population, and you take a sample. You know that it may not be exact, but with it being a sample, it's going to be an approximation, it's going to be an estimation. And so, yes, I would expect the results to be about the same. Next up is circle graphs. So a group of friends has been given $800 to host a party. They must decide how much money will be spent on food, drinks, paper products, music, and decorations. Mikkel presented the circle graph below with his recommendations on how to spend the money. How much did he choose to spend on food and drinks? How much did he choose to spend on music? When we look at our circle graph here, we can see that 16% of the budget he's proposing for decorations, 31% on music, 10% on paper products, 17% on drinks, and 26% on food. But we're being asked to identify what is the total amount of money he's choosing to spend it on. Each one of those sections represents, because our budget is $800. So that means of that $800, 26% of that money is going to go towards food. 17% of that money is going to go towards drinks. So we know the percentage, but we're being asked to find how much is he proposing to actually spend? What's that dollar amount? Remember, whenever we're dealing with percentages, when we want to find the percent of a number, we do so through multiplication. So we can take our percentages here and multiply them by the $800 to find out what 26% of 800 is, or so on. So now let's go back and reread this to see what exactly we're being asked. So we want to know how much he's going to spend on food and drinks. So food is 26% and drinks is 17%. We want food and drinks together based on this question. So let's add those percentages together. 26 plus 17 says that we are spending 43% of the budget on food and drinks. So we want to know what 43% of 800 is. The first step is whenever you're finding percent of a number, we need to change that percentage to a decimal. And you can do that one of two ways. You can either divide by 100, or a little shortcut to that is you can just move the decimal point 2 places. So this would be 0.43%. And then we're going to multiply that by 800 because that is our budget. So the decimal 43 hundredths times $800 is $344. So he's going to spend $344 on food and drinks. Now we want to know how much he's going to spend on music. Well, music makes up 31%. Once again, change that into a decimal. And if your calculator does have the percent sign and you're given permission to use a calculator, you can just type in 31% and it will go ahead and convert that to a decimal for you. But it is good to know that you just need to move the decimal point 2 times. And once again, we're going to multiply that by our total budget of $800. And we see that on music, he is proposing to spend $248 on that music. Now, I'm actually going to go back to the food and drink real quick and let's figure it out separately because maybe that's what you did. The question is a little ambiguous. You could, answer it with the food and drinks combined, which was my initial thought, but maybe it's just putting it together in one sentence. So if we want to quickly see what they are separately, in case that's what you did, food is 26%, which would be 0.26 as a decimal. And if we multiply that by 800, we see that he's wanting to spend $208 on food. And then if we go down to drinks, that was 17%, which is 0.17, and we multiply that by his budget of 800. And we see that he's wanting to spend $136. So if you did those separately, now you have those answers as well to double check. All right, let's move on to other types of graphical representations. So we are being asked here to select an appropriate type of display for each of these following situations. So our first one is the salaries of all 40 employees at a small company. Then we have the salaries of all 250 people at a mid-sized company, the distribution of colors in a bag of colored candies, and then the number of siblings students in the 7th grade class have. So if we back up a moment, there are lots of different type of graphical representations, but these are the ones we've really been focusing on this year. And this is a great thing to screenshot and add to your notes because each one explains, why or when that is the best to use. So if we look at the bar chart or the bar graph, that is, when in doubt, that's a good and safe choice. But typically it is best for comparing categories of smaller data sets. And you could even have a double bar graph if there's more than one set of data. Histogram, that's really good for large sets of data because it shows your data in ranges at the bottom. And with a histogram, your bars do not have any spaces between them. So visually, that's a difference there, just to help you know the difference visually between the two. But with a histogram, there's always ranges. A line chart or a line graph is always good whenever you are dealing with anything that happens over time. A pie chart or a circle graph, as we had just done, that is perfect when you have percentages or proportions. Stem and leaf plots, this is probably the one used least out of all of them. And the reason why is it's not good if you have a large amount of data. It's really only best if you have concise, small data. And then a box plot, that is great because it shows a good distribution. Like if you're wanting to know the min, the max, and the median, that is the best choice there. All right, so now that we've quickly reviewed that, let's go forward and see what we think for each one. All right, so the first one here, the salaries of all 40 employees at a small company. Well, it's at a small company and there's only 40 employees with salaries. I'm not seeing anything about time to have me do a line graph or anything about proportions or percentages to do a circle graph. So I'm kind of leaning towards either a bar graph or a box plot. And this one, I think you could argue either way. I am leaning a little bit more towards the box plot because maybe if they're trying to compare the salaries, they're trying to find the min, the max, and then they're trying to find that median. What's that middle salary? Kind of depends on what they're wanting to do with the data, but that possibly would be a better choice. So sometimes you need to know not only what is the data that you're given, but also what are you trying to project? What are you trying to show? Because that can, differentiate. So a bar graph would be an acceptable answer. I'm going to lean more towards box plot just because I feel like if you're trying to track the salaries, you're probably trying to see, where most people fit in. Then for the second one, this one's salaries of 250 people. So that is quite a bit of data. That's a large amount. So again, we could use a box plot. There would be nothing wrong with that. But also maybe because there's so many data points, there's 250 data points, maybe a histogram would be good. And we could represent the data in, ranges. We could say, all right, this is the $30,000 to $40,000 range, and then the $40,000 to $50,000 range. And that might help the information be presented in a more concise manner if we use ranges like in a histogram. All right, number 3, the distribution of colors in a bag of colored candies. This one, I would say there's probably not too many candy choices, so you could probably use a bar graph to represent this one. If you're being asked to identify percentages, you could go for a circle graph, but it doesn't say anything about that. So let's go for a bar graph. And notice with all of these, I'm, selecting an answer, but sometimes you would need more information, or if you don't have more information, then you can support it, which is what I'm doing verbally. I'm supporting my reasoning on why I'm choosing a bar graph over a circle graph. And the last one, the number of siblings students in the 7th grade class have. I say this would be, again, my bar graph might not be too bad because, most likely you could fit that pretty well across the bottom, or you could deal with percentages and you could put that in a circle graph. Either one would be good. So let's go ahead and say, circle graph since we've already used the bar graph, but either one of those could be valid solutions. So really, when you are picking a graphical representation, sometimes it stands out and is obvious to you. Like if it says that it has percentages or proportion, definitely a circle graph. If it's over time period, definitely a line graph. If you have ranges of values, definitely a histogram. But when you have a situation like this where they don't give you a lot of information, you just kind of got to roll with it like I did and say, all right, this is probably what they're going for. So I think this would be the best, and here's why. All right, last but not least, we are going to work with probability. So a bag contains green marbles and purple marbles. If a marble is randomly selected from the bag, the probability that it is green is 6/10, and the probability that it is purple is 4/10. Dylan draws a marble from the bag, notes its color, and returns it to the bag. He does this 50 times. Approximately how many times would you expect Dylan to draw a green marble? All right, as we go back and read through this, we see that the theoretical probability, so remember, theoretical probability is what you expect to happen, of drawing a green is 6/10, and the theoretical probability of it being purple is 4/10, because that's what we expect to happen. But now Dylan actually draws the marble and notates its color. That means he is now performing an experiment. So that then moves to experimental probability. And we are being asked to find approximately how many times would you expect Dylan to draw a green marble. Though we know that he's doing this 50 times, but we don't have his chart of him notating each color to find the exact experimental probability. Therefore, we can use our theoretical probability that it's a 0.6 of a chance that it's going to be green to give us our expectation. We can say we expect him to draw about this many green marbles if he does it 50 times. So there's a couple different ways that we can do this. Since our probability was given to us as a decimal, I'm going to use just regular multiplication. But if we had been given our theoretical probability as a fraction, you could also have used a proportion to set up and solve this. But we know that we have a 0.6 chance of drawing a green marble, and he is performing this experiment 50 times. So we simply need to multiply these together to see what a 6/10 out of 50 chance would be. And that is 30. So that means out of the 50 times Dylan draws a marble, we can predict that 30 of those times would result in him selecting a green marble.